I've helped statistics students for over 10 years. I can help you with your statistics. That's today on High Peak Education. Tell me, what is this null hypothesis, alternative hypothesis? What's the story?
When you're doing a test and you're looking for the p-value, or it tells you like based off of the confidence, and then depending on one tail or two tails, you either reject or you fail to reject, depending on the data.
There's definitely more to say here. The null hypothesis is always going to have, I'm going to suggest an equal sign. So it's always equal, or it's like greater than or equal, or less than or equal. So the only possible signs for a null hypothesis is the greater than or equal. You could have the less than or equal, or then just straight the equal sign. So those are the only possibilities. So hopefully you're getting the idea here. Null hypothesis always has an equals as part of it, whereas the alternative hypothesis always has a not equal to as part of it. So like a greater than, a less than, or a not equal to. Does that make sense?
Yes.
The null hypothesis is sometimes thought of as status quo, whereas the alternative hypothesis could be thought of as the research hypothesis. We're testing to see if the alternative hypothesis should be favored.
Yeah.
The reason we always set it up this way is because the null hypothesis is sort of typically assumed from, let's say, like a population. That's why we always put the subscript 0 on it. So like say like mu 0 or p subscript 0. The subscript 0 just means null. It just means like, status quo. Whereas the alternative hypothesis, the research hypothesis, supposes that maybe the situation is different than we originally thought. Maybe things are larger or smaller or just not equal to what we originally thought. That would be a right-tailed or left-tailed or two-tailed test. A good example would be like if HO is less than or equal to 40, but then H1 is greater than 40. Because we want to cover all possible values of what the true mean is. But the idea is that the alternative hypothesis, we typically take a sample, and the sample is the best estimate we have of what's going on based upon the data we've collected. And the idea is that the sample will tell us if the numbers we've collected from the sample seem to suggest that the null hypothesis should be rejected. That, in other words, status quo is no longer being upheld. So that's how we think about the null and the alternative hypothesis. So let's talk about binomial data sets. What exactly is a binomial distribution?
The binomial distribution is when you're measuring the number of successes.
Yeah, exactly. So it measures the likelihood of k successes with probability of success p with n trials. So the example I like to think of is, you ever play that yard game cornhole where you throw the bean bags onto the platform and everything? Imagine there's no hole in the platform, and imagine you score 1 point if you throw the beanbag on the platform and no points if it doesn't go on. So you can imagine, let's say n is 10. Out of 10 tosses, k is the number of successes. So k could be anywhere between 0 and 10. And then let's suppose I'm not a very good cornhole player. So let's just say my probability of success is like 0.23. So only 23% of my tosses get onto the platform. So that would be a binomial distribution. Binomial distribution is always Bernoulli trial. And Bernoulli trials are always going to be succeed or fail. It's going to be either 1 or 0. That's the way you think of Bernoulli trials. So every time you throw the beanbag onto the platform, if you get it on there, it's a success, counted as a 1. If you don't get it on there, that's a fail, counted as a 0. Football games. If the favored team won, we call that a success.
Yeah.
If the favored team lost, we call that a failure. Now, by the way, when the favored team loses, you could say the unfavored team won. Yeah, but with statistics, we got to keep our language tight, so it's very clear. So if we say the favored team won, that's a success. Use the language of the favored team lost is a failure. Let's not even worry about the other team because our focus is on keeping the language clear. But the binomial distribution discrete. That's because the number of trials can only be a positive integer. The number of successes can only be a non-negative integer. So 0, 1, 2, 3. And then the probability of success, it's like a typical probability. So it's going to be between 0 and 1. You know, a positive decimal number that's between 0 and 1.